So this talk is about there is a new vulnerability on 3G and 4G protocol. This is beyond what we know in the past, and how this can be exploited to track 3G, 4G mobile phone users. So my name is Ravishankar Borgaonkar. I work as a research fellow at University of Oxford,
and my name is Shinjo Park, and I am working as a PhD student at Technical University of Berlin.
Yeah, and this whole work was done with Lucca Hirschi. So he works at ETH Zurich. We discovered this work while doing some research back in Oxford, like 1.5 years back. And it took time to report this vulnerability to the standardization guys and then get the positive response that we can go ahead. And we then carried out the attacks with Shinjo and Altaf. So unfortunately, Lucca was supposed to be here, but he has his wedding the day after tomorrow. So his wife was not ready to let him to go black hat. I mean, you know who is the hardest person to convince something, and this is your wife, so this works. So what we're going to have in this talk, so some background I try to give what this protocol means and how this affects daily your life and how many times this protocol is executed on your mobile phone, which is completely invisible to you. Then some new privacy attacks, which we also, similar kind of attacks we presented last year in Black Hat London, that is Black Hat Europe in London, but those were completely different. So they also allow to track 4G users, but this is new variants of attacks. I'll try to give the reference. And those attacks in practice, how do you really do the demo? We actually really wanted to do the live demo, but in US, the regulations are different. We can't really run the 4G IMSI catcher here on the stage and we can show you. So we have a demo to run the 4G IMSI catcher, but we also had some backup if it doesn't go well. We could do on the SIM card as well, at least programming, but I tried to show the demos that we made a video and what are the impact against mobile users. Some countermeasures, what are the takeaway for end users, what are the takeaway for mobile operators, what they could fix their network to minimize the impact against the mobile, and what we'll see in 5G towards come to the conclusion. So now if I ask you, now as you are in this talk, I believe you know the mobile architecture, how does it look like? Again, this is too complex to explain like this figure. But I try to divide in a simple way. On the left side, you see, so we have this component called mobile and your SIM card, which you carry always in daily. This is connected to the tower, which is called any tower in the building. Let's assume like this in a general picture. And this is your mobile tower, and whole component is called as a radio access network. And all the attacks, what we covered today, will be on this part, like there is a tower and there is a mobile phone, and this is the protocol what you execute on this level. For this talk, we never consider core network, but only one element in the core network which we are interested, which is called, just for a reference, which is called authentication register. Let's say name this, like the technical term is home location register, but this is the element which really carry all your authentication token. Let's say first time when you buy a SIM card from any operator, like it has to be synchronized or it has to be authentication material which are stored in this component, which are really required for to make it operational. So this is just to give a general idea, but now we go a little bit detail. So what exactly happened only on this component? When you use your mobile phone wirelessly, what are the threats, how people really can track you, what the things can they see about you. And in the whole presentation, what we try to cover is only about 3G and 4G. I know there are plenty of research in GSM that people have done already. Already there are plenty of IMSI catchers you can see on the market as well. Those are IMSI catchers on GSM. But all the attacks, all the base stations, fake base stations we're going to talk, it's only on the 3G and 4G on this architecture. And of course, I try to tell there are some emerging threats as well coming, which we haven't seen in the past, and now we can do something new. So let's look at the picture. What is possible? What is the state now? So what are the ways you people being tracked? So as I explained, so this is one area where you have a base station, and this is a mobile phone when user is carrying, which is basically connected with a fixed line to your MNO, which is a mobile network operator. So let's assume this is T-Mobile or Vodafone. This could be any operator. And of course, this is connected back to the internet. So this is like a general architecture whenever your mobile phone is connected to the network. And now what are the threats on this triangle? I try to divide first this circle, second is mobile operator, third is over internet. So let's assume attacker is sitting on the internet, like he's just using normal internet, maybe back in London, and now what he could do against you because you are sitting in Las Vegas, right? So what are the threats? On internet, there are ways to track you particularly. Also interception, but not full level. I mean, there are some talks about you can use SS7 services, which has got a lot of media attention as well last couple of years back. So SS7 flaws can be used to track your location, try to intercept your calls. Also a simple service like HLR lookup, which is still free. Everybody can access this service, and you can really, for example, if you know the mobile phone number, you can get the IMSI of a target, or some services try to give you location as well. Just Google and you will find plenty of services that allows you to tracking people based on the mobile phone number. So which you can do easily on the internet. That's everybody knows threat. Second is, okay, fine. What attacker could do, he can try to sum up the network element of mobile operator by a number of means. Either try to infect some machine which is being inside the core network. We have seen some example of WannaCry malware actually. Of course it was ransomware, so actually it was affected to one of the European operator, and their components was really, they had some service down. So similar way, somebody could try to have implant to the network and they can steal some information. I mean, if you get access to some of the components, I mean, you still have a way to track some subscriber activities so this is like interface, and then you try to do further attacks over the core network. Like there is a possibility. And there is a famous Greek scandal. I don't know how many people know in this room. I could have asked the question, but we were running out of time. So this is the famous Greek scandal where one big agency actually compromised a Greek operator, and actually they put some malware on the LI interface, which was provided by Ericsson. So what it had an impact. They were able to monitor every subscriber in the Greece actually by using this lawful interception implant. And this is a very well-known case of compromising mobile operator. So this is another way you can track any mobile users, particularly of the target. The third thing is, which is really popular, which is part of this talk, we're going to see about this, which is Stingray, or I try to say fake base stations. So during the presentation, I use the word Stingray or fake base stations. So somebody can bring these fake base stations, no matter 2G, 3G, 4G, and they try to track you or they try to intercept you. And another method is, okay, you try to infect the mobile phone itself, which we have seen, for example, Pegasus, which there is a talk already in Black Hat. Google is going to talk about, I think, on Pegasus. So you try to infect the mobile phone itself, or try to locate the activity, or try to get his calls by different means. So it's about compromising the mobile operating systems rather than the mobile network part at the same time. So these are the four elements. So in this talk, we covered this only, like what happens if somebody brings Stingray for 3G and 4G networks, and how you track mobile users by different means now. So these are the new techniques on this interface, how people can track. I know that nowadays you can buy a solution that you can try to detect IMSI catches. But this talk gives you a highlight how people can build smartly IMSI catches so that they can be harder to detect. I'm not saying impossible, but harder to detect. And this will we try to cover on this aspect now. So this is just to give a brief overview what things we are coming up. And now when I talk about tracking using a fake base stations, I believe some of the guys already know this threat. I try to give some reference to what is the key thing on the mobile phone which is being tracked by these guys. So everybody is carrying mobile phone with a SIM card, which has some unique identities. The first is called IMEI, which is International Mobile Subscriber Identity, which is unique to your mobile phone. And the second element is IMSI, which is called International Mobile Subscriber Identity, which is on your SIM card whenever you buy SIM card. And this doesn't change at all. As long as you keep the same SIM card for 4 or 5 years, I mean, your number is same, so you will be identified by this single number. So these are the elements which IMSI catchers try to track. And the fake base station, somebody can bring the fake base stations, which could be run on 2G. And 3G and 4G. If you carefully look the catalogs, there are some in media, actually some people did research, what are those product brochures and catalog who sell those IMSI catches. And if you look at those IMSI catches, they also mention 3G and 4G. But look carefully, they try to always downgrade users to 2G and then they do the tracking and interception. So it's not fully fledged 4G, 3G, it's about the downgrading the users. But again, we are having new smartphones nowadays. I mean, not every smartphone, which you can lock on a certain 4G networks, let's assume that. But I mean, those are the technical challenges which we haven't solved, but fine. So you can configure Stingray for 3G and 4G, and you try to grab the IMSI or IMSI or different means to track person. So this is about what exactly Stingray works. But in the process, technically, what they really do, so they have a protocol, in authentication protocol, which mobile phone talks to the base station whenever it sees a new base station. And this protocol in GSM was really badly designed. So any base station can come and ask, hey, let's try to connect and give me your IMSI, and that's it. You just leak your privacy identifier. This got corrected in 3G and 4G, so they improvised this thing now. So they got the new protocol, which is called Authentication and Key Agreement Protocol. So it's no longer easy to bring a fake base station and try to mimic as a real network. So you need some kind of an extra effort to work to let your IMSI catcher work for interception purpose. So it's not that easy in 3G and 4G. And now we'll look exactly what this protocol is. And that's what this protocol plays key role to protect the users against, I would not say against fake base station attack, but it makes fake base stations life a little bit harder about the attack. So what this protocol is, just to give reference. So it's deployed in every 3G, 4G terminals. Any IoT device, you can name it. You can name a car or any device which having a SIM card. Which is, I'm using this term SIM card, but in 3G, 4G, we try to use as a USIM, which is called universal SIM card. And this is deployed since 2002. So it's been almost like 15 years this protocol is running on your devices. As I mentioned, this has been improvised in 3G, 4G, that it provides you mutual authentication between your network, which is basically a tower, and a mobile phone to establish a secure link. And there are different kind of encryption levels in 3G. There are more advanced in 4G to protect against the interception attacks. And again, the key sizes are really increased in 4G. So like in GSM, you can capture the traffic and you can brute force as well. So there is already available rainbow tables to decrypt your calls. But this is no longer possible in 3G and 4G because algorithms are improvised, which is not really possible, which is the effect there. And if I give example, I mean, if you ask any crypto expert, what is the most successful protocol by crypto standard? So they're going to say, okay, this authentication key agreement protocol is the most successful, widely deployed protocol in the world because it is running on billions of devices which you're carrying IoT device, mobile devices, which having a SIM card. So this is one of the great examples. This protocol is so much successful in terms of successful. But for this talk, there are two elements which are important for this protocol, which are, first thing is this protocol uses symmetric key mechanism, which is a key which is shared between your SIM card and your network service provider, which has an element called HLR, home location register, basically. So this is your authentication register, which shares the same key which is having your SIM card. So nobody can get this key at all. And there is a sequence number to avoid the replay attacks. So what does this mean, replay attack? If I talk about GSM, if you've done any man-in-the-middle attack and you grab some authentication material over the air, actually you can play this numerous times as a replay because there is no mechanism in GSM to see that whether this has been replayed. And that's what this sequence number gives you a mutual authentication property, which is the improvised version. And let's talk a little bit about this protocol. What is state of art? What we know about this protocol before we now dig into the details. What are the known problems of this protocol? The first is IMSI leakage. Everybody knows that IMSI is being leaked. Like if you bring any 3G and 4G base station and you ask for IMSI, it can give you straight ahead because there is no protection for that because the architecture is designed in such a way that. So still people can track you based on IMSI. I mean, easy attack. The second is linkability attack. I will not go in detail, but during the explanation, I will talk about what this linkability attacks means. Just give a simple example. Let's assume Shinjo is here and there is another guy with orange t-shirt here. Both are actually having a mobile phone. What I do now, I bring the fake base stations right here like this. And what I do, I try to send one packet to orange guy and the same packet to Shinjo. Now what happened during authentication, if this packet belongs to Shinjo, this phone will just say, okay, this token is belong to me, but there is some problem, and it gives you error like sync failure, okay? Because this was belong to him, but I'm trying to replay the same token. So his phone gonna say me sync failure, there is a problem. But if I send to this orange guy, it's gonna send you MAC failure. Now simply by looking at this response, what the phone tells, you can really say that this is my target, because he told me sync failure message. So I was looking for this particular guy. And when this sync it doesn't belong to this orange t-shirt guy, so you're gonna get like MAC failure. So looking at the failure response message, what you get from the mobile, actually you can really pinpoint who is the target. So like again, simple, I mean they had a protection, but like by looking at the failure message, you can discover who is the right guy. So privacy attack. Actually we told this attack in 2012 to GSMA and 3GPP, and actually they acknowledged the report, but there is nothing we could do because it's a specification attack at the same time. And we also know that the thing has been changed. Now we have the availability of low-cost hardware and software tools which we can try to do many attacks, or at the same time attacker can also level up their game. So they can also have easily available infrastructure. They have open source software as well to do numerous attacks like this. So I'm not surprised that there are many vendors nowadays who sells IMSI catchers also for 3G and 4G, also and 2G, because things are getting low cost and stack is available. And now let's go back, what is the flaw? So I try to explain what this flaw is. So I just try to give the protocol sequence now, what we will see. So there are 3 elements in the protocol. So we have on the left side mobile, then the base station, which is on your tower, and the network, which is, let's assume it's a T-Mobile network. Now what really happens, so let's assume that the mobile is trying to do authentication. So we call this procedure as a user authentication. So this time mobile has to tell what is my identity. The second time, once the base station get this message from mobile phone, base stations are, I mean, they don't know anything. They are just they are just a device which can relay the message. So he just sent this information to the network saying, hey, there is one guy from T-Mobile and he wants to authenticate. Can you give me his authentication data? So this tapes, it will just collect the authentication material, which we say authentication tokens, which comes to the base station. Base station stores those tokens. It gives some kind of a challenge to your mobile phone saying that, hey, let's authenticate now, and responds to your challenge. So you get the challenge. If the challenge is correct, you are successful. If the challenge has some problem, it's gonna say, let's try to synchronize. You are the right guy, but there is some problem in case of a failure. And if all steps are fine, so this is like a procedure, and then you do successful authentication. So these four steps which are essential. What are the problems in each step? What we know. This is the place where all your Stingray or IMSI catchers work. This is the simple techniques what they use. So at this current state, they exploit this flaw on this stage. Second, which I told you, failure message, like a MAC failure or sync failure during authentication. By using this, they can also try to detect you are the right guy. All these methods to bypass detection mechanism what you have on the mobile or in the infrastructure anywhere. But now in this talk, we have the vulnerability which weren't disclosed in the past on 2 elements, which are, first is authentication material, which we fetch by producing a fake SIM card. So we build a fake SIM card of a target user, and we collect this authentication material on behalf of him. And we use these tokens to locate or to make a new attacks on the users. That's what this is different. And we also exploit the 4th procedure in the protocol, which is called resynchronization. And if you combine both of these, and then that's introduce a new attack. So this is just to give a big picture and what comes in the next slide. Now I quickly run over the protocol, what really it contains. But this just to give a brief overview, but I'll try to focus which element is important. So this is just now technical means I try to put the slides. So on the left side, you have a mobile and authentication center, which is basically an HLR, technical term we call authentication center, which are essential things. So you see on the left, this is the K, which is the unique key shared between your SIM card and AUC. So both parties going to have the same SIM card. And this is on lifetime, when you're carrying a SIM card, it's going to remain the same. And there is a sequence number on your SIM card, which is always stored. And the same sequence number is actually stored on operator side, which is on AUC. So these are like a fixed known values which are stored. So let's do, when you turn on your mobile phone after landing in Las Vegas, so what exactly happens? I try to explain this procedure now. So you turn on your mobile phone. So your mobile phone sends request to mobile network saying, hey, I wanted to authenticate. So I mean, this RNC means radio network controller, which can also be the base station. But base station is only used in 2G because your encryption ends on the base station in 2G, but not in 3G and 4G. That's what I use this RNC element there. And MSC is mobile switching center or visiting location register, which you use while you're roaming. So the mobile phone, so identity has been asked, which is IMSI. So it gives the IMSI. RNC gives back the authentication center saying there is a guy from Vodafone UK which came to Las Vegas, he wants to authenticate. So query goes back to UK, to straight ahead to the my operator Vodafone in UK. It collects the authentication request for this guy. So they perform all these crypto operations in UK. They bundle all these elements called XRES, which is called response, CK, which is ciphering key, IK is called integrity key, this is anonymity key, and a MAC. So they compute all these elements. They send this element back in US for the mobile user, and out of these tokens, these elements are sent via the base station. For example, let's say in this area, and only the base station going to send me RAND and AUTN, only 2 challenges out of this sequence, which basically AUTN means the sequence number, what exactly used for authentication or verifying the sequence, which is XOR with AK, with anonymity key. So it's not in plain text. So if you're sitting as a man-in-the-middle attack here, you're not going to see in plain text, basically, which really identifies the user or see the sequence. And this is like a MAC and AMF, which is the bit, which we ignore right at this moment. So this goes back to mobile phone. Mobile phone, again, pre-computes all these values based on the RAND and these tokens because they have the same algorithms. Your SIM card has the same algorithm like your operator. So this value again calculated, they verify the AUTN and compute the response. The response sends back to the operator, which is in Vegas. They verify if this equal, then say fine. Now you are the right guy, and let's talk to each other. And then you have the encrypted session. So from here onward, any attacker who's sitting in the man in the middle, he cannot really see anything because it's encryption here. The point is, I wanted to come on this slide now. This bit, which is called AUTN, which has the sequence number XORed with anonymity key. So let's see what exactly this sequence number is and how important it is in terms of, and of course that's what this given protection, because you see anonymity key is never, all these keys are never sent over the air. So attacker never have these keys. Attacker only sees RAND and AUTN, that's it. Now how attacker can find out this sequence number by cancelling out AK or without having any key, we'll just explore now in detail. And yes, this is like resynchronization procedure if something goes wrong, but this is relevant for the next attack. Now, what is the role of sequence number? Now, if you really have a chance to design any protocol, maybe back in when you were engineering, I mean, you just designed protocol, or maybe in your school or college time, or just as a hobby. So SQN numbers, when we design a protocol, I mean, when we design a protocol, we need to have a replay protection. We need to make sure that there is a freshness. So simple thing, you can use a nonce, so that every time you talk to two parties, so there is a nonce there to replay attacks. Same thing, they use sequence number this time, because that saves one round trip time to the AUC. Because if you use nonce, so two parties have to send nonce, and then you agree on some computation, so it's like saves one time message. But anyway, so AUC authentication center, like your operator, saves this SQN and increment for each authentication. So let's assume I got a SIM card, what I tried to tell you. I turn on this SIM card, and my SIM card, when do authentication, it will be having sequence number 1. And at the same time, HLR, which AUC, which also have the sequence number 1. So in your lifetime, your sequence number will be going to increment by +1 always. And it will not be 0 at all, because then the crypto property will be just, you lose all the properties. So sequence number should be monotically increased continuously. And it should be also, and it should be masked with anonymity key, so that attacker on the wireless link should not see this sequence number at all. Because if you see the sequence number, you can still predict the guy, or you can predict the next sequence number, which can really have a problem with the mutual authentication property. So it's masked with anonymity key AK. And the good thing is about your SIM card, which is USIM, always store the highest sequence number you receive from the operator, and it always keep the state. So this makes this protocol as a protocol with a state. So it's a stateful protocol authentication key agreement. And in case of a failure, so when there is a failure happen, I try to tell you which are the failure cases. So your USIM must send the current sequence number to authentication center. So let's assume my SIM card is right now at the number of 50, and I go to UK. I landed at the airport and I try to authenticate. So what happens when they collect the new tokens? Actually, I'm going to get the sequence number, let's assume 100, because I use all these tokens being in Las Vegas, but those were not used. And if my SIM card says, okay, there is a new tokens coming 100 number, they says, okay, it's out of sequence. You should get the 51 correctly. So they try to do the resynchronization procedure. And during this time, your SIM card sent the operator saying that, hey, I'm at the 50 number now and I should get 51. And actually they send this number back to the operator using the new key, which is called anonymity key, but AK star. This has been computed differently, again encrypted, so the attacker won't see this at all. So on the wireless, you don't see anything. So that's the role of sequence number, to know exactly what state mobile phone device and the network is during the authentication. And just to give a significance, what exactly the point I'm trying to cover now for this attack. So avoiding all these crypto details, I think slides will be available and the paper as well. So the focus is basically, this is first authentication procedure I explained. This is authentication token collection. This is the base station send you all these queries. This box try to tell you that when you receive the sequence number, which is really too high or too low, your SIM card should tell the operator exactly what's the problem. And this procedure, what it does in sync failure, it tells the network, okay, I'm right now, this is my current sequence number, and it sends to the network. So this is significance of this message, just to give an understanding. I think hope everything is clear at this point. And now we go, what is the real vulnerability on this procedure? So what it leaks the number. The good thing about this sequence number is, so there is a standardization body called 3GPP who designed this protocol back in 2002. And that's what this protocol should be in every SIM card which you're using. So the sequence number can be updated by 1, or it could be a time-based value. But in the practice, what we have seen while doing the demos, while collecting the data within the Europe, not a single operator was using time-based sequence number. It has some drawbacks and some drawbacks, because when you do out of synchronization, the time-based value isn't really efficient. So it still allows too much round trip time to the network. So this is not really effective policy. So it's a time-based, but all our attacks are still relevant no matter which method your operator is using for sequence number. Now let's look at what is the new vulnerability. So this is just the background. Sorry it took a long time, but I just need to give a significance what exactly we're going to see now. So the first attack vector is on this figure of third part authentication material. So what you do on this authentication material. So there's request challenges. So whenever you request all this authentication material, so this procedure is never authenticated. So you don't need to have authentication, because they choose the method to have a symmetric key. And when you design a symmetric key, it's pretty hard to do authentication before you exchange the keys or anything, right? That's the classical drawback of symmetric key encryption mechanism. So, and in turn, you can request n number of times all these authentication materials from the operator. I try to give reference to what exactly this impact. So this is the first segment of this attack. What this privacy impact means, what we did in the attack, the SIM card, we bought a SIM card from like a dummy SIM card. You can buy it from China or from some other websites. So you bought any 3G or 4G SIM card. Let's assume you know your target IMSI. You put in this mobile phone, and what you do by sitting remotely anywhere in the world, actually, you can collect all the authentication tokens of any target in advance, which are unused at all. So basically, you have all the authentication material of a target. There is no rate limited network, so you just collected like 1,000 tokens, which can use any time to track some people. You don't need to have an IMSI catcher, or you don't need to have an IMSI to track user. So this is new way of tracking, which allows to reuse the locate. But in practice, now you may wonder, I mean, in practice, how do you exploit this flaw, right? So first you need to know the IMSI of a target, right? I mean, I must admit, okay, it's easy to do tracking based on IMSI, but as you know that people are moving towards detecting IMSI catches and finding the guy with the IMSI, which gives alert easily. So these are like a new techniques. This allows a new technique to build an IMSI catcher. So what you do in this new technique, so you need to know the IMSI of a target, right? So you can simply use HLR lookup service. So I think if some people doesn't know what is HLR lookup service, you can use the HLR lookup service. What it really does, you just put the phone number, like you register for a SMS bulk service, you put the phone number, in response you get this information back. What this information contains, which contains the IMSI of this mobile phone number. And actually, when you buy these services on the internet, you will see that which country's mobile phone number you can access. So you can get the service which mobile country you want. And just put the mobile phone number, you get the IMSI. Previously, it used to also give the location as well, not the precise one, but the city level information. Like right now, you're in Vegas, and anybody can know just by putting this phone number there. But this has been limited now, and still some operators actually gives the IMSI stated. So this is one way to get the IMSI. Once you get the IMSI, what you need to do, you buy this SIM card from anywhere. You reprogram a SIM card with this known IMSI of your target. No other keys required. Simple tool. We develop a simple tool so you can reprogram this SIM card with the IMSI, and then you collect all this RAND and AUT and authentication material pair, which I explained previously. So you just need to collect, let's assume 500 tokens, RAND and AUT, and which you can do less than 10 minutes. Simple. We develop like an Android app which can easily fetch all these tokens. You just put SIM card and just you collect all the tokens which you're going to use for tracking anytime. This is first thing, and then what you do in attack, so basically you bring your fake base stations while doing the location attack. You send the RAND and AUTN. Let's assume that everybody's sitting in this room now, and I need to find exactly one guy out of this room. So what my IMSI cacher will do, which is 4G, which will not send any IMSI request, which will just get the tokens, which will just get the identities and send all the 1,000 phones in this area RAND and AUTN pair, right? And when you send this RAND and AUTN pair, only one guy whose tokens I have collected being in UK or anywhere in the world. So actually this phone responds me with an authentication response. So I can really say, okay, this is my guy because he is responding to my token. Other guy is going to just give me the MAC failure. So I exactly pinpoint the guy which is exactly in this area right now. So this is like a different way of locating the guy. And you just track, same. And last year, as I mentioned in Black Hat London, we had a talk actually. You can use the similar setup once you know the guy, but you cannot really find exact location of the guy within the 2-kilometer area. But actually, you can use this flaws which hasn't been fixed because it's a specification flaw. It has been addressed in the standard. Actually, you can still get the GPS coordinate of the guy, which this was the research we published last year actually in Black Hat London. So you can still get the GPS or GPS coordinates or the triangulation method coordinates of the guy where the guy is right now in the 2-kilometer area. So you can pinpoint the target by doing the extension of attack. So this is about the location. This is no. So what exactly I presented here, a new technique a smart IMSI catcher can build onto their platform and they can track people. So the goal is fine. There are some techniques available to detect IMSI catchers, but this technique is really hard to detect because we're not really making a false request or trying to be authenticate and go away or try to block the phone, anything. So there is no other techniques used. Simple protocol behaving as a network and you can still locate the user. So this is like a bypassing the detection. But now, what the something new you do, and this is from this attack, is now we exploit this sequence number. We try to know what exactly the sequence number is. Now, if you look back the protocol, I try to give the thing now. I explained. So this is like a notation. I try to give simple meaning what it is. So network sent to the mobile, sending this is RAND, and actually this is your AUTN, which basically SQN which is encrypted with AK, masked with AK and a MAC. Let's assume there is a sync failure. What happens, I try to remind you, your mobile phone sends back to the network SQN XOR AK, like this element. The key thing or the key vulnerability on this procedure is if you replay a new token, if you replay the same RAND and AUTN to the mobile phone user after 1 day, so let's assume I collected a token from Shinjo's mobile phone today, this RAND and AUTN, and I replay, and I'm just going to get the same message saying that, hey, there is a sync failure, and here is the sequence number. So I don't know sequence number is encrypted. If I send the same query after 2 days, I'm going to get the response SQN star AK, but this time this SQN will be greater because he has been using his mobile phone for 2 days. So what I'm going to get SQN number, but the key thing is, while designing the protocol, they forget that there is a chance to do a replay attack. So we're doing a replay attack here, but we're doing a replay attack sending the same RAND and AUTN, but we are just looking for this AK star key. Now what happens in combination, if you look at this figure C1 is equal to SQN at the stage of 1, let's say, XOR with AK star. I send the same message after 2 days to this guy. SQN has been increased. Let's assume this is SQN2 XOR with AK star key because I'm using the same RAND and token which I use once. I'm going to get this sequence, and if you XOR these two elements, simple computation, C1 XOR X2, you're going to cancel out AK star and AK star because these are the same keys. And if you cancel out this AK star, what the equation you're going to get, C1 XOR C2, then you're going to get sequence number 1, which was 2 days back, and this is sequence number 2 XOR with today. So you're going to get this value. So actually you cancel out the AK star key, which masked your sequence number, which is the key element in the protocol. And by knowing this equation, we design an algorithm so that we can learn the bits of this sequence number. So actually we can reveal exactly what the sequence number his SIM card is at this stage. And by learning this sequence number with this vulnerability, what new attacks which we can do now, which is we call activity monitoring attacks. So what are those attacks about monitoring the user? First is we learn the insignificant bits of this sequence number, what exactly, and as I explained, in lifetime of a SIM card, those will be continuously increased by +1. And the second is we can know at what time he was using or how much mobile phone he was using by looking at the pattern. So what it implies basically, let me tell you frankly what happens. Whenever you make any phone calls over 3G and 4G, when you make a phone call, operator wants to see whether you have paid for money or not, and that's what they need to do, authentication, and they want to check whether you paid. Every time you make a call, you do authentication, it means your sequence number goes to +1. And this doesn't happen in practice. Like in 4G, 3G, it's so much secure. They do authentication for every, let's assume, 10 to 15 calls. So I assume that you make a call after 10 calls, there is one authentication. So you can learn the pattern. When you learn the pattern, you see there is a sequence number increasing. So no matter Shinjo comes after a month, I can inject the same packet to his SIM card, and I can know, okay, now after 1 month sequence number has been increased from 50 to 200. So I learned that, okay, how many calls he made. Same thing if I do the same next day attack, and actually I can figure out whether his phone was yesterday switch off or it was on, or how many calls he made. I can try to predict exactly. He tried to make few calls or few SMS over the night, and no matter when he comes next time. So it's like whenever I see this target, I can exactly see how much the mobile phone he is using or activity. Of course, I cannot intercept his data. I cannot see the text message, but I can infer his activity, what he is doing. This is just some extra hint. You try to monitor the activity, what he is doing. So it's a new type of threat. But once we know all sequence number bits, actually, again, you lose the property of protocol mutual authentication. So you're going to have the same attacks. Somebody can bring the face station, and you basically running on the same level of GSM. So you don't have the same properties. Location attack, which I already mentioned. So this is the algorithm about learning n bits. I think I skipped that, but feel free to ask once we share the slide. Detail about this algorithm, how we really learn the sequence number bit. And the proof of concept, now I try to give the demo, live demo. So basically what we do, we reprogram the SIM card we put into phone, just to give example, we collect the tokens, we use the 4G IMSI catcher, and we inject to the mobile phone. Before the demo, I just asked Shinjo to explain the experimental setup, and I just run quickly through the demo.
Okay, so for the demonstration of our attacks, we have used USRP B210 hardware, and we also used we can use any kind of smart card reader to program any kind of programmable USIM cards. The image on the top right-hand side is USRP B210, and the one below is the smart card reader, which we have used during our experiment. But yeah, as I said before, any kind of smart card reader could be used. So, and we also used the software called PySim and OpenLT, and we introduced our own modifications there. Because PySim by default,
you can explain.
Yeah, PySim by default, it supports only GSM authentication. So we implemented a UMTS ACA authentication inside the PySim code. And for the OpenLT code, while it is functioning just as a normal LT base station, but we have implemented another capability that allows us to inject any kind of RAND and AUTN tokens, which to any kind of the mobile phones, which is connecting to our OpenLT base station instead. So we have prepared a demonstration video, and we will walk through the step-by-steps of how the experiment is going on this video.
Okay, so first thing is, let's see how we really see the SIM card particularly, right? As I explained initially, you get this IMSI over the internet. You configured, now we configure this SIM card with the IMSI number. So you just put the IMSI right in there. That's it. Now it has the target IMSI inside. And he's doing maybe in London right now. That's okay. So what he's doing, just for the demonstration, he's putting this in some mobile phone and try to do fake authentication to the network by still being in UK. Now you see he authentication will fail because he doesn't have all the keys. But what happens? He got the tokens now. Just to give a significance, and this is all this stuff. What we're running is now in the Faraday cage. So what we do, we get these tokens, and we try to set up an 4G IMSI catcher, which is now running. You see. Now on the left side, you'll see the light which is blinking now. It's sending the signal, which is the LTE signals in the Faraday cage. And now you this token replay and see the response, how the phone really behaves. Now there are two cases. First is about any random phone try to connect our fake base stations, and we send the same tokens to everybody. So it tries to authenticate, but it gonna fails because this is not his token. So he's the bad guy. This is not our target. Now we send the same token. It's like a Mac failure. So it's like this is not the right guy. He's a different guy. Now, when the target is about to connect our 4G IMSI catcher, and we send the same tokens what we collected using the SIM card, and there will be authentication fail, but it doesn't say fail message. You're going to say it's success message. You will see now on the screen. So you see authentication response you received, and you see that, okay, it's accepted the AUTN value, and you're going to get the. So this time there is authentication response, which is basically a successful message because you got the response. This is RES. This is the right guy says, fine, I accepted the token. You got it now. And this is about how you learn the sequence number. So we had this algorithm, and we just run the AUTS combination by injecting the packets within the time of 10 minutes. And then you try to infer what exactly sequence. And you need to do only one this attack for per particular user, and that's like straight ahead. So you try to get what the number is. You do the same computation again, just for linkability. So yeah, so you try to see. So you see there, we actually in a short period of time we get this. Like in 10 minutes, we basically get this much bits of sequence number, which are again unique by knowing. So by this, actually, we know exactly what sequence number he is, and next time, whenever he comes in our target area, we locate him and we try to see how much mobile phone he has been using yesterday, or whether it was switch off, he made some calls or not. We try to infer those attacks by learning this. So going quickly to the slides, we almost. Yeah, so I think, as I explained, all these attacks with the cost of $1,400 US. Like again, these are the different modern IMSI catcher attacks. You learn the 10 bits of sequence number just by 12 injections and 64 eavesdrop with a SIM card. Like that's much speed. Of course, you can increase the speed by efficient signaling. Once you learn the sequence number, you just have the same thing. Observations in the deployed network, as I explained, there is an issue with the window of acceptance sequence number value. If you look at the protocol design, actually, you should not accept sequence number of 1,000 greater than value, because this is not really useful for mutual authentication. And we have seen in the wild, there is not a single effective policy operators we're using, actually, and no clear requirements in the standard. So it was like some guidelines, but it's not a mandatory what operators should do. And the funny thing is, when I asked some operator, hey, what the policy should you are using? And he said, we don't know, and it's been running from last 10 years. We just use default value what we have. And who set this default value? Like a vendor, Huawei or Ericsson or Nokia. So they don't exactly know what exactly the policy they are running. I mean, they are unaware of what exactly happening behind. And different policies of this one, and of course risk policy. I just try to go on quickly the problem actually. The thing is with the SIM card, you reprogram SIM card of any user actually in the world, and you can continuously fetch the tokens. And there is no rate limit at HLR that one guy asking all the authentication tokens and you are just sending by any means. This is the same thing somebody tried to do SS7 attacks. They can prevent, but this attack is a little bit harder to detect as a rate limit, because this is coming as a legal message which is coming from some country, like let's suppose it from UK. So this is again harder to detect at the same time. And we tested in a few European mobile operators. Of course, so protection is needed, but we don't know. I mean, this is standardization flaw. We have been informed to the 3GPP body. They acknowledge. We also give presentation to GSMA, so they are thinking about making some kind of a guideline for how the sequence number value should be acceptance and rejections. Let's hope what exactly happened there. And impact again the end user. So this is like a new threads. It's an activity monitoring attack. Somebody can learn exactly what you are doing. I mean, the similar types of techniques or the products you are seeing on a Wi-Fi, like you go on a shopping mall and they try to see how much, I mean, when you're using Wi-Fi, they track to observe your behavior, right? So this is like the same behavioral track using an IMSI catcher about the user. And new location attack, which are harder to detect and fix and bypass the IMSI catcher detection tools, affect 3G and 4G. And with the 5G context, I want to end on this line. I think I can skip. I have two slides. Yeah. So I think countermeasure sites, as I explained, for mobile operators, evaluate your SQN acceptance policy. If there are operators, actually you need to revisit exactly what you are doing on a sequence number. Evaluate the rate limit if there is a possible protection or not, but this is harder to implement. I mean, because the devices which you are running on authentication server, these are really old and they won't allow any modification in the software as long as at least my information, but which is pretty hard. And end users, I mean, you can't do anything as long as you don't want to use SIM card being tracked. So you can use your mobile phone, but use Wi-Fi. But if you use a SIM card, you tend to being tracked by any means over 3G and 4G network as well. Again, this is the new, different kind of attack. And for vendors, hopefully fake base stations will no longer work in 5G, which we also work in the 5G protocol design. And support for legacy network, which is really makes this effort challenging. So I think many people have a hope that your IMSI catcher problem or Stingray devices problem will be fixed in 5G. But I mean, as a protocol designer, I have some experience. I mean, I see that even they have some kind of a public key encryption mechanism. I mean, there is a still way that IMSI catcher will work at least for tracking. They may not work for interception, but tracking may be somehow possible, but we don't know exactly. The 3GPP is doing really great work. They are designing the 5G right now, so hopefully they address all the requirement. So we may see that 5G, this problem will be fixed in 5G. But right now, the vulnerability, what we mentioned to the operator, I mean, it barely, even they fixed it, it's really hard to come into your SIM card because your SIM card needs to modify to fix this vulnerability, and which is no longer possible in this ecosystem. I mean, this highlights again the problem that we are using the mobile phone, we are upgrading your Android, everything, but upgrades to your SIM card software or anything, I mean, there is no way you can upgrade anything. I mean, you're still stuck in the same like 20 years back security in this world. Conclusion, I just quickly end on this side, and you have a question and answer. And this is the point I'm ending. So this is the document which is right now going on standardization of 5GPP, and they already agreed that they're going to use the EAPIACA protocol for 5G. But we don't know exactly what the protocol they're going to change. But there is a saying that this protocol will be used in 5G again. As long as it has some modification, I mean, you will see that the IMSI catcher problem will be fixed. Other than that, you're going to have the same problem in future as well. So that's it, and I hope I passed 1 minute or 7 minutes. If you have any questions, we can talk near the stage, or feel free to catch me in nearby places. Yeah, thanks.